right, so this lesson is an introduction to simple probability. So what is probability? So probability is the likelihood of an event happening. So likelihood, hopefully I spelled that right. The likelihood of an event happening, and it is expressed as a number between 0 and 1. So it's a numerical value that tells you how likely something is to occur. So from 0 to 1, at the bottom end of the scale, 0 would be impossible. So if something has a probability of 0, that means that it's impossible for it to happen. Um, let's see, what's something that would be impossible? How about the probability that you can make yourself invisible? That probability is 0, at least today. Maybe one day you can make yourself invisible, but today it's probably impossible. And then let's go to number 1 over here. So number 1, what we say, it's the opposite end of the scale, and then we say it's certain. So the probability is certain. That means it's gonna happen. So let's say what's the probability of you? Oh gosh, what popped in my head was saying of you dying. It's a terrible thing to say, but the probability of you dying is certain. It's gonna happen one day. Should have thought of a better example before that one came up. Oh well. So in the middle, if something has a probability of 1/2 or 0.5, then we say that it's equally likely. And what do we mean by that? We mean that it's as equally likely to occur as to not occur. So basically, you can think of it like a 50-50 chance. So like flipping a coin. So if you flip a coin, it's equally likely to land on heads or tails. And in between impossible and equally likely is unlikely. In between equally likely and certain is likely. So the further you go down the scale, the more likely something is to occur. At one end, at 0, you have impossible. At the other end, at 1, you have certain. In the middle, you have equally likely. Could occur or not occur. It's equally likely, each one. And then unlikely and likely in between. So let's look at some examples of this. So read each example and label the situation with one of the terms above. So snowing when it's 40 degrees outside. So I teach in Florida, so my students probably will have trouble with this question. But if you live up north, you know that if it's 40 degrees outside, it's not going to snow. So you need a temperature of 32 or less, right, for water to freeze. So this would be impossible because water can't freeze at 40 degrees. Like I said, my students probably will be like, what? That's really cold. Number 2, burning your dinner if you cook it too long. So if you cook your dinner too long, is it definitely going to be burned? Or maybe it's going to be burned? So I think the best answer here would be to say likely. So it's not certain. You could cook your dinner too long and not burn it, but it could happen. And it probably will, right? So it's likely. You could argue that this could be equally likely, and I don't know. I probably would agree with you. Water boiling at 75 degrees Fahrenheit. So hopefully you've taken science classes and learned that water does not boil at 75 degrees. And while I know what temperature water freezes at, I don't know what temperature it boils at. I want to say 120, but I'm not sure. That's why I teach math. Number 4, getting a ticket if you are speeding. So just because you're speeding doesn't mean that you're going to get a ticket, but it's definitely more likely that you're going to get a ticket if you're speeding. scoring from a safety in a football game. So if you don't know anything about football, then you're going to have a really difficult time with this question. But I will tell you that it is unlikely to score from a safety. It doesn't happen very often in football. How about a coin landing on heads when it's flipped? So there's an equal chance of it landing on heads or tails. So that would be equally likely. Sorry, I had to pause that for a second because my wife was calling to see if I needed anything from the grocery store. Sorry. So, moving right along. So, the simple probability is the ratio of successful outcomes, successful outcomes to the total number of outcomes. So basically, it's how many ways can what you want to occur versus what are all the possible things that could occur. So for instance, like if you were rolling a die and you were looking at what's the probability of rolling an even number. Okay, so how many ways are there to get an even number? How many successful outcomes are there on a die? So there's 2, 4, and 6. So there's 3 successful outcomes to get an even number. And there's 6 possible outcomes, 6 total outcomes. So the probability of rolling an even number would be 3 over 6. And you could simplify that to 1 half. The probability of rolling an even number is 1 half. And so remember, 1 half means equally likely. So you're equally likely to roll an even number as you are to roll an odd number, right? Or to not roll an even number. So for instance, if we were looking at so this is how we say probability. We say P parentheses A. That means the probability of this event A occurring. So what we do is we say we count how many ways are there for A to occur over what are the total number of outcomes? How many things could happen? So like on a die, a number cube, that would be 6, right? That's the total number of outcomes. If I was looking at the probability of an even number, how many ways are there to get an even number? There's 3. So it'd be 3 over 6, and we would simplify that to 1 half. The probability of the event not occurring, so the probability of not rolling an even number, we call that the complement. And the probability of the event and its complement have a sum of 1. So what does that mean? So the probability of A happening, right? This is how many ways A can't happen. So the probability of not A, so this little parentheses here means not. So the probability of not A happening would be how many ways are there to not have A happen over the total outcomes. And this all sounds a little confusing. I get it. Like I'm sitting here struggling how to explain this to you. But as we do examples, I think this will become a lot more clear. Okay, so just stick with this and wait for the examples, and I think you'll understand. So for instance, there are 4 circles here. No, sorry, 5 circles here. And it says, what is the probability of choosing a marble with stripes? Okay, so how many marbles are there with stripes? There's 1. And then how many total marbles are there? There's 5. So the probability is 1/5. So remember, anything between 0 and 1 half is unlikely. So the probability of this happening, we would say, is unlikely. So if you were to reach your hand in a bag with these marbles, the probability of you pulling out the striped one is unlikely because there's 4 of them in there that are not striped and there's only 1 that is. All right, now we look at the probability of not getting diamonds. So here's the parentheses, that means not. So how many marbles are there that are not diamonds? One, two, three. Because there's two of them that have diamonds, right? So there's three that are not diamonds. So there's three ways to not get diamonds out of five possible outcomes or total outcomes. So 3/5 is more than a half. So this would be likely. All right. So let's look at this spinner here, right? So like in a board game, you spin it, right? So that's what we're doing here. It's a spinner. And so what's the probability of you spinning this and getting a W? All right. So how many ways are there to get a W on here? Well, there's only one. There's only one section with W's. And then on the numerator, I mean on the denominator, excuse me, on the bottom here, the denominator, would be the total number of outcomes. So you just count how many sections are on here. 1, 2, 3, 4, 5, 6, 7. So it'd be 1/7. And that's definitely less than a half. So that would be unlikely. So you would be unlikely to spin that and land on W. Now it's not impossible, right? You definitely could spin this and get on W, but it's not likely that you would. All right, and then the probability of a vowel. All right, so we're looking at A, E, I, O, U. So A, E, I, O, U. How many of, oh wait, sorry, probability of not a vowel. My bad. So not a vowel, the parentheses here. So A, E, I, O, U are vowels. Everything else are not vowels. So there's two vowels, these A's here. Everything else is not a vowel. So that means there's 5 segments that are not vowels out of 7. And again, that would be likely because that's more than a half. All right. Again, just keep in mind, like if you're still confused, back it up and listen to it a couple times. And hopefully, if I didn't make it sound too confusing, then you'll pick it up. All right, so let's look at some more examples here. So you got a standard number cube or a die. Just in case you don't know, if a die is a singular form of the word dice. Dice means more than one die. Although most people, when they speak about them, they just talk about dice, whether it's one or more. But the singular form is die. So a standard number cube is rolled, so it's got the numbers 1 through 6 on it. What is the probability of rolling a 6? Well, how many 6s are there on the die? There's 1. And how many possible outcomes are there? There's 6, because there's 6 numbers on the cube. And so 1/6, that's less than a half. So just to keep coming back to the words here, this would be unlikely. All right, what about the probability of rolling a 5? Well, how many 5s are there on the die? There's 1. How many possible outcomes or total outcomes? There's 6. And again, that's the same thing. It's unlikely. So you're just as likely to roll a 6 as you are to roll a 5. That's what the probability value tells you. You're just as likely to roll a 6 as you are to roll a 5. The probability for both of them are the same. Okay, what about an odd number? So odd numbers are 1, 3, 5, 7, 9, 11. So how many odd numbers are there on the die? 1, 3, and 5. So there's 3 of them out of 6 total outcomes. And we simplify that to 1/2. So these are equally likely to occur. So you're just as likely, that says likely, trust me, you're just as likely to roll an odd number as you are to not roll an odd number, right? Half the numbers are odd and half of them are even. All right, what about a laundry basket has 24 socks in it, 6 were navy, 10 were black, and the remaining were white. What is the probability of drawing a black sock? Okay, so how many black socks are there in the laundry basket? There's 10. So our numerator is 10. That's the number of successful outcomes. Over, what's the number of possible or total outcomes? So we got to count how many socks are in there. So there's 24 socks. So it's 10 24ths. I'm going to simplify these by, that would be 5/12. 5/12 is less than a half. 6/12 would be a half. So this is unlikely. All right, what about a white sock? Let's see. The remaining were white. Let's figure out how many were white. So there's 6 navy, 10 black. So 6 plus 10 is 16. So subtract that from 24. And that means that there are 8 white socks out of 24 total socks. And that simplifies to 1/3. 1/3 is less than a half. So that would be unlikely. I missed an L up here, didn't I? Unlikely. That's terrible. Sorry. All right, navy sock. So how many navy socks are there? There were 6. So that's 6 out of 24. Simplify that. And you get 1/4. And that again is unlikely. All right. Back to a spinner here. So the spinner below is spun. What is the probability of spinning not a 6? All right, so how many numbers on here are not 6? Well, let's see how many total numbers are. 1, 2, 3, 4, 5, 6, 7. All right, so my denominator is 7. There's 7 total outcomes. How many of the numbers are not 6? Well, 6 of them. And that would be likely. So you're likely to spin this and not get a 6. What about a 3 or a 4? All right, so we haven't seen this before. Word or here. So that's saying 3 or 4 is a favorable outcome or a successful outcome. So if we land on 3 or 4, that's good. So how many ways are there to land on 3 or 4? There's 2 ways, right? Because there's 1 3 and 1 4 out of 7. And this would be unlikely. Likely. I'm having trouble writing today. Unlikely, because that's less than a half. An odd number, so that would be 1, 3, and 5, and 7. 1, 3, 5, 7. So there's 4 odd numbers out of 7. That's more than a half. So that would be likely. Right? The letters in the word soccer are put into a bag. So just think about, you have like tiles with letters on them. So you have a tile with an S, an O, a C, C, E, O. Right? Are put in a bag and drawn randomly. What is the probability of choosing a vowel? All right, so first of all, how many tiles are there? So there's 1, 2, 3, 4, 5, 6, or letters. So there's 6 letters. How many of the letters are vowels? A, E, I, O, and U. There are 2, O and E, and that simplifies to 1/3. So that's less than a half, so that would be unlikely. All right, what about consonants? So everything that's not a vowel is a consonant. So really, this question would be the same as if it said, what's the probability of not a vowel? Because everything that's not a vowel is a consonant. So if there's 2 vowels, that means the rest of them are consonants. And so that would be 4 out of 6. And that simplifies to 2/3, which is more than a half. And so that would be likely. And what about the letter C? So how many letter C's are there? There's 2 out of 6. So that would be 1/3 that would be unlikely because that's less than a half. All right, so I got one more slide for you here. Moving right along. At the pediatrician's office, patients are able to draw a toy from the toy bin. The toy bin has 12 puzzles, 16 boxes of crayons, and 2 bouncy balls. What is the probability of drawing anything but a bouncy ball? Okay, so let's first see how many things are in there. So we have, I'm just going to put it up here, 12 plus 16 plus 2, so there's 12 puzzles, 16 boxes of crayons, and 2 bouncy balls. So that's 28 plus 2, that's 30. All right, so my denominator is 30. Anything but a bouncy ball. So how many things are there that are not bouncy balls? Well, there's 2 bouncy balls, and everything else is a bouncy ball. So that would be 28 out of 30. We can divide those by 2, and that would give us 14/15, which that would be likely. That's more than a half. And what about a box of crayons? So we got 16 boxes of crayons out of 30. That would simplify to 8/15. That's more than half. So 16 is more than half of 30. 8 is more than half of 15. So that would be likely. And then lastly, a puzzle. So there's 12 puzzles out of 13 total items. What can we divide those? We can divide both those by 6. So that would be 2/15. That's less than a half. So that would be unlikely. All right. In the movie drawer, there are 7 action movies. So once upon a time, people used to have DVDs to watch movies. Now we just stream everything. So in the movie drawer, there are 7 action movies, 5 comedies, and 3 dramas. So we've got 7 action movies plus 5 comedies plus 3 dramas. So that's 15 total movies in the drawer. So dramas, we have 3 dramas out of 15 total movies. So that simplifies to 1/5, and that's definitely less than a half. So that would be unlikely. Anything but a comedy. Another way of saying this, by the way, is not a comedy. Okay. So there's 5 comedies. The rest of them are not comedies. 15 total movies. Take away 5. 10 movies that are not comedies out of 15. And that would be 2/3. That's more than a half. So that would be likely. An action movie. So it says there are 7 action movies out of 15. You can't simplify that. 7 is less than half of 15. So that would be unlikely. All right, last piece here. Whoops. I dragged the wrong thing. Let me move this out of the way. Students standing in line for lunch were surveyed about their favorite meal. Their responses are shown below. If one student is picked randomly, then which of the following is true? So 26 students said their favorite meal is pizza, 8 said spaghetti, and 16 said fajitas. All right, so first let's think about how many total students there are. So let's add this together. So 26 plus 8 is 34, plus 16 is 50. So they interviewed 50 total students. And they're asking us which of the following statements is true. So the student's favorite meal is half as likely or equally as likely to be pizza than spaghetti. So is pizza equally as likely to be a favorite meal as spaghetti? The answer is no. A lot more students like pizza than like spaghetti. The student's favorite, so let me cross that off. The student's favorite meal is more likely to be fajitas than pizza. Well, no, more students said they like pizza. So, nope. The student's favorite meal is twice as likely to be spaghetti than pizza. No. Less people said they like spaghetti than like pizza. We've only got one left. The student's favorite meal is twice as likely to be fajitas than spaghetti. So, were there twice as many students that like fajitas versus spaghetti? The answer is yes. So, D is our answer. So, I know that was kind of long, but I hope you got an understanding of simple probability. If so, give it a like and a subscribe, and feel free to leave me a comment if I can improve anything. Until next time.